All right, so thanks so much for sticking around. It's been a long weekend with a lot of great talks. I was at PyTexas 2019, but this is my first time speaking at one. Yeah. So my talk is going to be a bit different than the ones you've heard before. I'm going to talk to you today about how you can use Python for digital investigations. First, I'm going to talk to you about what a digital investigation is in this context. Then I'm going to show you an example of a digital investigation. I'll show you some Python tools that my colleagues and I have used for digital investigations. And I'll close with some more information in case you're interested and want to get more involved. There we go. All right, so I've been programming with Python for about 10 years now. I learned it in college, mostly for computational physics. In my current job, I am a data scientist and developer at Bellingcat, where I do a lot of large-scale social media scraping and analysis, and developing software tools for journalists and researchers to use. I'm particularly interested in far-right extremist communities online, and a lot of my research focuses on that. So Bellingcat is a nonprofit investigative research collective founded in 2014. We use open source data to investigate a wide variety of topics, including human rights abuses, environmental issues, wrongdoings by the powerful, the radical fringes of society, and just about everything in between. We publish stories, develop novel investigative methods. We share those methods with journalists and researchers, and foster a community of people who use those methods. If you've heard of Bellingcat before, it was probably when we identified the Russian intelligence agencies, intelligence agents who poisoned the dissident Alexei Navalny, or something similar. Yeah. So what is a digital investigation? You might also hear the term open source research, which I'll be using throughout this talk, or open source intelligence, often abbreviated as OSINT. The big idea here is that this is information that is available to the public. Everyone has equal access to the information sources. They're not classified by government or locked away in some company's proprietary database. And the key thing about this is that the equal access to information sources enables a great deal of transparency. Investigative methods can be shared. This increases accountability. Anyone can verify the steps that researchers have taken, which in turn helps in reproducibility. Investigations can be confirmed and expanded upon by others. And these kinds of open source investigations have really only been around for about the last decade or so. Previously, a lot of sources were really only available to the intelligence agencies of powerful governments. But now, many of those sources are available to anyone. For example, right now, if you have about $100, you can buy a satellite image of anywhere in the world with sub-meter resolution. And that's just something you really could not do 10 years ago. And as you may have heard or noticed, there is a lot of information on the internet. And that can make things challenging when you're digging around trying to find some specific content. But the upside of that is that the list of open sources is pretty much endless. The only real limit is the ingenuity of researchers. So some common examples of open source materials are geospatial sources like Google or Yandex Maps, Google Earth, and satellite imagery. We have media outlets, BBC, CNN, Fox News, user-generated and social media content like from YouTube, Twitter, and Telegram, and data sets, for example, for things like company registration and legal documents, as well as archives like the Internet Archive. Often, the really interesting thing comes when you combine information from several of these sources. And also it's worth mentioning that things like hacking, stealing, and spying are not considered open source, and Bellingcat doesn't do those. So let's get into an example of an open source investigation. So on July 17th, 2014, Malaysia Airlines Flight 17, known as MH17, which was flying from Amsterdam to Kuala Lumpur, was shot down over eastern Ukraine. All on board, nearly 300 passengers and crew were killed. In the immediate aftermath, the Russian government blamed Ukraine, and the Ukrainian government blamed Russian-backed separatists in the region. If we don't want to trust either of these governments or their intelligence agencies, what can we learn from open sources? Turns out we can learn quite a bit. So in the days before and after MH17 was shot down, there were several sightings of a military convoy near the location of the crash site that contained a missile launcher. Many of these sightings were posted on social media, such as this Instagram picture. And by determining the location of each of these sightings, researchers were able to piece together the movement of the missile launcher. So we're interested in this particular missile launcher from this particular convoy for a key reason. In footage before July 17th, the launcher has 4 missiles. After July 17th, it only has 3. So this is suggestive that this is in fact the missile launcher we're looking for that shot down MH17. So an essential step when we're working with social media information and content is verification. Basically, does the image or video actually show what the post claims it shows? There's a lot of things we need to watch out for with this. So for example, is the video a repost of an event that happened earlier? We see this in war footage all the time. Like especially drone footage is constantly re-uploaded and recycled and claiming to be from the most recent conflict. Is the video generated by a video game or flight simulator? This is actually surprisingly common, especially in aerial footage. Has a video been deceptively edited, like slowed down, sped up, or had some other footage spliced in? And more recently, a more recent issue, was this generated by AI or Midjourney? Does everyone have the right number of fingers and legs? So luckily, there are some well-established methods for investigating each of these points, but we don't have a ton of time for that, so let's just focus on one of them. Is the location where the post claims the actual location of the video? So what we see here, in the top, we have a screenshot from Google Street View, and at the bottom, we have the video of the missile launcher, as well as and if you're in Google Street View, you can adjust the viewpoint, and you can kind of line up the viewport with the actual video. And we can see, okay, so there's a pole that looks about right. There's another telephone pole. The intersections of the wires on the pole look about right. The outline of the trees also looks right. So we can say, okay, it's plausible that this video was in fact taken at this particular location. And in practice, geolocating footage often requires either very detailed knowledge of a particular location, being very clever, or just brute forcing it and spending a bunch of time driving around Google Street View or flying around Google Earth. But the key point is that no matter how difficult and long it took to geolocate some footage, pretty much anyone can verify it. Like it really doesn't require much specialized skill to look at a location in Google Street View, look at video, and be able to say, oh yeah, this, and this match up. Or conversely, to say, oh no, this doesn't match up because of this and this. So it's very much a democratization of investigation. So the key point is, by geolocating each of the sightings of this convoy, both in Ukraine immediately before and after the shootdown, and in Russia about a month earlier, researchers were able to convincingly argue that that the missile launcher traveled from Russia to Ukraine to an area controlled by Russian-backed separatists, and then after the shootdown, traveled back with one less missile. They were also able to determine the Russian unit the missile launcher belonged to, and all these findings were later corroborated by the official investigation by the Dutch government. And to reiterate, this was all done without having to trust the word or propaganda of any intelligence agencies or government. And this is just one example of the power of open source research. So a common source of confusion is the similarity of the terms open source research and open source software. I intentionally use the term digital investigation in my talk to avoid confusing you all, because I assume most of you are familiar with open source in the context of software, not research. And though the two terms sound similar, they have very different origins. The term open source intelligence, OSINT, really originated in the US and British intelligence communities as kind of a catch-all term for non-classified sources of information. Despite the different histories, though, the two communities have really independently converged on a similar ethos, really built on transparency, reproducibility, and collaboration. And kind of going back to Krishi's talk yesterday, all these are ways of kind of building and establishing trust. And in the last few years especially, the overlap between the two communities, the open source research community and the open source software community, the overlap has been increasing. And this is really driven by two factors. One is that open source researchers and journalists get more familiar with software tools, for example, learning how to run Python scripts or use the command line to automate some of their tasks, like the boring ones. And at the same time, developers find out about open source research. They think it's cool, so they start developing tools for it. And that's kind of the path that I took. It's worth mentioning, though, that there is still a long way to go. Bellingcat surveyed researchers and found that only about a quarter of them are comfortable using software tools from sites like GitHub. And that tells us that there's a lot of opportunities, both for education and for making tools more accessible and easy to use. So Python has become the go-to programming language of the open source research community for many of the same reasons that you all like it. I'm assuming here that you all like Python since you're at a Python convention, but if not, I'm sorry to hear that. So I mean, as we know, Python is easy to learn, especially as the first programming language, and it has a very mature ecosystem of packages for just about any purpose, from web scraping to image analysis to 3D modeling. So the first Python tool I want to talk to you about is the Auto Archiver, developed by some of my colleagues at Bellingcat. It automatically archives posts, images, and video from a variety of social media platforms. The way it works is that researchers paste a URL of a social media post into a Google Sheet, and then any media, metadata, and a screenshot of the post is automatically downloaded and saved. And we wanted to make this interface as easy to use as possible for non-technical researchers, right? Simple is better than complex. And this kind of archiving is actually really important for sensitive social media content. Something that we see all the time is that some social media account will post something that is interesting or revealing or just kind of spicy in some way, and then take it down as soon as they realize, hey, this makes me look bad. This is especially damaging if the thing that looks bad is a potential war crime, and when they take it down, all evidence of that content is now gone. However, if we have archived it, then we have it, right? So the Auto Archiver uses a mix of both official and unofficial social media APIs, basically whatever does the job the best, and you can check it out on our GitHub page here. So at Bellingcat, we use Google Sheets pretty extensively. They're easy to use and set up. They're easy to collaborate with non-technical people, and they're quick to read and adjust formatting, which is good for manually checking data. We typically use the gspread Python package pretty extensively for reading and writing to Google Sheets. And what we have here is a screenshot of one of the inputs to the Auto Archiver that we have been using to track incidents of civilian harm in Ukraine, so such as attacks on infrastructure and against the population. So since the beginning of the Russian invasion last February, Bellingcat and volunteers have geolocated and verified more than 1,000 incidents of civilian harm in Ukraine. Each incident can be visualized on our time map website. Let's try this live. Oh no. Come on. All right, there we go. Third time's the charm, right? All right, so what we see here is a map of Ukraine, and we can see circles that represent all verified incidents over the last month. If we click on one of these, zooms in and focuses on the individual incidents, and if we click on one, we see that on March 9th, there was a strike on a industrial area. It's not loading right now, but I hope you'll believe me when I say that we have the Telegram video of the strike for anyone to see. And I will say, sorry if this is a blasphemous thing to say, the front end is not Python. It is JavaScript, but the source of the data was all done in Python. And several other organizations are using the auto-archiver for similar purposes. And one thing that's worth mentioning is that one thing Bellingcat has been working on is developing a methodology for making open source evidence, for making open source data admissible as evidence in international criminal law proceedings. The goal here is that the geolocated and verified footage that was archived by the auto-archiver will one day be used to hold accountable members of the Russian military who were responsible for these attacks on civilians. Yeah. Another Python tool that Bellingcat has developed is a framework for scraping social media content, not just a single specified post like the auto-archiver, but everything from a set of accounts or channels. We developed this framework as part of a data-driven effort to better understand the ecosystem of QAnon and QAnon-adjacent online conspiracy communities in Europe, because that's a big thing in Europe, believe it or not. We collected a lot of data. We have posts from 5 different social media platforms, including Getter, Rumble, BitChute, and VKontakte, which is like a Russian Facebook. But the vast majority are from Telegram, because that's the platform these communities are most active on. We are archiving posts from about 2,600 channels. So by channel, I refer to really any kind of social media account, so a BitChute user, a VKontakte group, or a Telegram channel. And as of last night, we're up to about 63 million posts that have been scraped, archived, and made searchable. The posts contain about 44 different languages, which have at least 100 posts. We have nearly 6 million images that have been archived and OCR'd. So we're using optical character recognition to detect and index text in image. And we have about 2 million videos. So the way this works is that the framework coordinates between the scrapers, the database, and the media archive. We use the SQL Alchemy package to interface with the database, the Elasticsearch package to interface with the full text search index, but we use Boto3 to archive content, PyTesseract for OCR, and Flask for the API that communicates with the front-end dashboard. Similar to the auto-archiver, researchers can paste the URL of a channel into a Google Sheet, and then the framework scrapes the raw social media posts in near real time. And in addition to scraping, we're archiving media files attached to posts, which along with images and video can include things like audio and PDF documents. The scraping, archiving, and processing pipelines are constantly running, so even if a channel quickly deletes a post, there's a decent chance we'll still get it. The raw post is then cleaned and processed into a standard format across platforms, which makes it searchable through a front-end dashboard we created in JavaScript. So to better understand the overall structure of the ecosystem, I created some network visualizations from the data. Let's see if this works. Nice. All right, so this first network shows Telegram forwards. So the nodes, the circles here, are Telegram channels. Edges between nodes, the lines, are in one channel forwarded one or more posts from the other. The nodes are colored by the most commonly detected language in the channel's posts. So we have this German cluster in kind of teal, English in orange, Italian in blue, French in pink. And the node size is related to the number of followers the channel has. One nice thing about this network is that the clusters of nodes are very tight and correspond closely with the channel languages. I mean, this makes some sense, right? If you have a social media account, you're not going to repost content from a language you don't understand. And what's an interesting thing is that the positions of the language clusters tell us about how the different language communities interact with each other. So as you can see, English is at the center of the visualization, and it kind of acts as a hub that connects the different European languages. If we zoom in a bit, let's see, yeah, so this Dutch cluster, kind of in green, here is very close to the English cluster, indicating that there's a lot of overlap between the two communities. And one thing that I think is particularly interesting and useful about this kind of visualization is that we can identify some key nodes that stand between clusters. For example, this one we see, we see a lot of nodes, edges coming in and out of this one that connect the English and French communities. So investigating bridge nodes like this can better inform how viral content moves between communities and across borders. Let's see. Nice. All right. So in the second network, what we have, so the nodes are named entities, basically words that correspond to real-world objects detected using SPACY, a natural language processing package in Python. And the edges are when one or more posts contains both named entities. Nodes are colored by a community detection algorithm that seeks to group together similar nodes. And this kind of visualization is really interesting to see how different topics relate to each other according to these conspiracy communities. There are a few clear clusters. In the center, we have, in purple, we have this kind of U.S. politics thing with various politicians, the FBI, and patriots. Over here, we have in green, kind of a more COVID one. We have things like COVID, WHO, Bill Gates, Anthony Fauci. And one thing I really like about this kind of visualization is that it's good for finding kind of niche topics and subcommunities. Like, for example, there's something called Schumann resonance, which is a geophysics phenomenon. It's commonly mentioned in weather and geoengineering conspiracies. And investigating that, I hadn't heard of this before, and investigating that took me down a fun rabbit hole. Where did it go? All right, so the last tool I want to show you is called Sugartrail. It's used to find and analyze connections between companies registered in the United Kingdom in the Companies House database. Sugartrail was one of the winning projects in Bellingcat's first hackathon, and its developer continued to work on it, funded by a Bellingcat Tech Fellowship, which we offer to developers of tools that we find interesting and useful. Sugartrail has an easy-to-use interface implemented using IPyWidgets that uses requests to interface with the Companies House API and pandas for data processing. You can see here, this is a screenshot of the interface, which was developed using IPyWidgets, which basically converts a Jupyter notebook into a interactive web page, which is quite cool. And Sugartrail, oh god, okay. So Sugartrail can do several types of investigations, including identifying addresses that are registered, that one or more companies are registered, and that's useful for finding potentially suspicious offices with lots of registered companies. It can also, probably I think the coolest thing is that it can see if and how two different specified companies are related to each other by following the chain of companies, company officers, and registered addresses. And these types of analysis are useful for detecting potentially fraudulent companies and company officers. And these are especially useful to financial investigators who don't know programming and don't know how to, use an API or use a huge database. And this can save them from for like hours and hours from doing a bunch of manual work, tracking down the leads manually. So, taking a step back, why should you care about this? I mean, if you haven't figured out by now, one of the main reasons I'm here is to get developers like you all interested in open source research. I can tell you my perspective. The thing that really keeps me in this field and interested is the impact. My colleagues and I work to expose some really terrible people, whether that's military officers who program cruise missiles to hit children's playgrounds, or neo-Nazi pedophiles. The work we do helps to hold these people accountable and find justice for their victims. It's incredibly rewarding work. And the other thing that really keeps me interested is the just sheer energy of the open source research community. This field has really only been around for about 10 years now, but researchers are constantly coming up with innovative uses of open source information. I've really only scratched the surface here. I could spend hours talking about brilliant open source investigations and tools, like when a researcher identified secret US military bases in Syria because soldiers were logging their runs to a running app. Or one of the coolest things I've seen recently, it's a tool that uses small fluctuations in GPS satellite signals to detect North Korean missile launches. And another aspect that I think is really exciting is that often these software tools don't have to be very technically sophisticated to be really useful. I mean, often it's the simplest tools that get the most usage and impact. Something as straightforward as a wrapper or an interface to an existing API can be a game changer to people who don't know how to use requests, which, let's face it, is most people. And no matter your skill level, you can meaningfully contribute. And I mean, like Pandy said, we can build anything, right? So that's the end of my presentation. If you want more information, read our investigations on our website, bellingcat.com. You can see our repos on GitHub, Bellingcat. If you really want a challenge, we see our list of open questions. These are difficult, long-term challenges that I'd love to see anyone make some progress on. We maintain a list of tools used in open source research. Check it out at bit.ly/bcattools. In 3 weeks from now, we'll be hosting a virtual hackathon where we'll be focusing on making digital investigation tools more accessible. If you Google Bellingcat Hackathon, it should be one of the first results, or you can follow this link or talk to me. And if you want to get more involved, Bellingcat has a Discord server where you can join a community of open source researchers who are working on a ton of really cool projects. And if you have any questions, please don't hesitate to come up and talk to me. I love talking about this stuff and think it's really exciting. And I hope you all do too. Thanks so much. I hope I left. Yeah.